guys to remember, on Thursday, we're going to do the graphing test. All right? What I want to do in this chapter is kind of split it up a little bit. Because like I said, the second half of this chapter is completely unlike the first half. So I want to get the graphing out of the way, because not only is it kind of like a weird setup of the chapter, but the other part of it is that this week and next week are kind of all messed up anyway because of conferences. So if I try to continue you guys to remember all the rules about graphing and then all the rules about everything else we're going to go through in this chapter, it might become a little bit more painful towards you. So I thought I'd cut you a little slack, and that's so very nice of me, right? We'll just split it into two parts. Now, here's what happens when we shift the tangents. We actually go through the same process as we did with sines and cosines. We're going to plot our parent graphs. We're going to plot them with dotted lines, just like you would earlier. Then we're going to shift them left and right, up and down, depending upon the h's and the k's. Remember, all the same rules apply. h's go horizontal, k's go vertical. What's going to get messy with the tangent shifts are going to be the asymptotes. Okay, that's what's going to get kind of messy, because you're going to have a lot of dotted lines going on. You're going to have overlaps going back and forth. It gets a little bit messy looking. So as long as we pay attention to where things are coming from and where they're going, it's not going to be that bad. So let's take a look. So your tangent graph, just like the sines and the cosines, has the A, H, and K component, A, B, H, and K. So always meter y equals A tangent of B, parentheses, x minus H plus K. Remember, the B value is always going to be outside of the parentheses. Sometimes it might be needed to might needed to be factored out of the parentheses. I think I had an example of that the first day I gave you guys shifting problems. I just forgot to tell you about it. So if that comes up again, I'll rework it with you. But the rules about H and K still hold true. So let's look at an example. So the example I have here is y equals -2 tangent of parentheses x plus pi over 4. So this seems like it's old hat by now. What do you think the first step is going to be? Yeah, label out what you know. Label out what you know. A, B, H, K. Well, what's A? -2. What's B? 1, H. Good. Negative pi over 4, and then K is 0. So do we all agree that this thing's, when we graph this, we're going to eventually have to shift it to the left, pi over 4? Do we agree on that?
Yes.
Okay. There's no vertical component to worry about, so we still have to identify our period. Remember, the period for tangent is always going to be pi, bless you, divided by the absolute value of b. Well, what's the period in this case? Pi. Very good. Now, the original asymptotes are going to always occur at your period divided by 2. Okay? Since the parent function always goes through the origin, I know that my original asymptotes are going to be at plus or minus pi over 2. Does that make sense? So I start with that. Once again, I'm using a little bit of foreshadowing here, knowing that I'm going to have to shift it to the left. I might make the left side a little bit longer, just so I have a little bit more room. I know that the original graph is going to go through the origin. I know it's going to go through 0. Bless you. I know that the asymptote is going to be at pi over 2 and negative pi over 2. That gives me the period between here and here at pi. Okay. That distance is pi. All that's left is to get the critical values in between. Remember, the critical values for tangent for the parent function are going to occur between 0 and the asymptote, and 0 and the other asymptote. So what's halfway between 0 and pi over 2? And then the negative pi over 4. And now what occurs at those halfway points? The shift, yeah, the a value. So our a value is negative 2. Now, since the a value is negative, will the tangent be moving from quadrant 4 to quadrant 1, or quadrant 3 to quadrant, quadrant 3 to quadrant 1, or quadrant 2 to quadrant 4? 2 to 4. So it'll be at here, here, here. And there's my parent function. Okay. Remember, the a value tells you what direction it's going. If it's a negative value, it's just going the opposite of what the normal would be. So now for each of these points, we have our original set at negative pi over 4 and 2, 0, 0. Hey, what's up? Please. By all means. And all I'm doing is just labeling out my 3 critical points. And then we know that our asymptotes were at x equals plus or minus pi over 2. I know that's where my 2 original asymptotes were. Okay. Remember, I'm having you guys do this because I'm holding you accountable for the critical points, so you don't just draw wavy lines that you found on your calculator. Okay? So now, what do we do to each one of these points? We shift it. If we move them to the left, pi over 4. Just move all this up. Now, I know that you guys hate fractions. And the reason I know that because you're high school students. I'm trying to just move this out of the way. Let's move it backward. Now, remember, we talked about this yesterday. Your calculators won't keep pi in their answers, but we all agree that each one of these fractions is negative 1/2, negative 1/4, 1/4, negative 1, and positive 1/2, if I just get rid of the pi for right now. We all agree on that. So, if you're not sure how to use the calculators, or do the fractions in your head, use the calculator. Put them in parentheses. Use that alpha y equals button to create the fraction. Then take your asymptotes. Your new asymptote's going to be at, well, if I take negative pi over 2 and I move it to the left, pi over 4, well, that's 1/4 minus a fourth. What do you get? It's negative 1/2 minus a fourth. 3/4.
3/4.
Negative 3/4. So my new asymptote for here is going to be over here at negative 3 pi over 4. Okay? Why? I'm starting here, I'm taking negative 1/2, and I'm subtracting 1/4. Got to move your asymptotes too. Yeah, basically all of these things, all 5 of those values move. Just like we did with sines and cosines, we moved all the points we found, left, right, up, and down. We do that with tangent too, but we also have to move the asymptotes. Okay? And when I'm working with tangents and I'm plotting shifted tangents, I always start with my asymptotes. Okay? So I know that the first asymptote will be at negative 3 pi over 4. The other asymptote, when I take 1/2 and I subtract 1/4, what do you get? You get 1/4. So that asymptote will be here at 1/4. So it'll be pi over 4. So now this is my new boundary. This distance is still a period of pi. That period doesn't change. That overall distance doesn't change. All I did is I just moved it from here to here. That's it. well, but okay. All I'm doing is moving those asymptotes over. Okay? You okay? All right. Now that we did that, all you have to do is now find out where the new center is going to be. Once again, if you go to the origin and you move it to the left, pi over 4, you wind up at negative pi over 4. So I knew that my first point will be here. If I'm at pi over 4, and I move it to the left pi over 4, I'm now at 0. And if I was here at pi over 4 and I go to the left pi over 4, I'm at negative pi over 2. So my scale just looks nasty, but it's been shifted. It's been shifted. Now, once again, what you could do, if you take your 5 points you find right away when you write them out, just take all your, since you're only moving left, take all your x coordinates and subtract 1/4 from each one of them. That'll give you new sets of ordered pairs. So your new ordered pairs are going to be, well, negative pi over 2 and 2. Negative pi over 4 and 0. And then pi over 4 and positive. No, excuse me, pi over 4 and negative 2. And then lastly, our new asymptotes, where at x equals negative 3 pi over 4 and pi over 4. Oh, yeah, this is supposed to be 0. Thank you. I saw that. I saw the red and I thought it was right there. Thank you. Okay? So remember, if all else fails and you're having problems with your fractions, all you need to be able to do is make these lists of the first set of points, and if it's got a pi in the numerator, just leave the pi out of it when you're using your calculator. Get the new fractions, write it down. Create a scale, and you're done. Okay? And that's what it looks like. Okay? It looks like you're really buying it. You got that sheet from yesterday? Most of you guys handed it in. I just wanted. Thank you. There was some more on here. Oh, there's no shifting tangents. Ooh. I thought there were shifting tangents. All right, let's do another one. Well, that looks nasty. So it's y equals 5 minus tangent to x minus pi. Let's walk through this one. Y equals 5 minus tangent of 2, parentheses, x minus pi. Broken record time. What do you think the first step is? Yep. Table them out. What's your A value? -1, very good. Your B value? 2. H and K. Good. So does everybody see in this case that we will have to shift it to the right pi and up pi? Everybody agree on that? All right. So now we have to figure out what our period is. Remember the period for tangent is going to be pi over the absolute value of 2. So it's pi over 2. Which means your asymptotes are going to be where? Very good. Your original asymptotes are going to be at pi over 4. Remember, in order to figure out where your original asymptotes are going to wind up, you're just finding half of the period. The easy way to do that is just multiply it by 1/2. Okay? So now you have enough information to plot your original graph. Since I'm going to be moving to the right and going up, I'm going to start the graph off a little bit more to the bottom left, just to have space. Okay. All I'm doing is moving it over a little bit to start with, so I have a little bit more room when we shift. All right. Excuse me. So first thing I do is I plot my asymptotes. So my asymptotes be at negative pi over 4 and positive pi over 4. I'm going to be at 0. The halfway points are going to be where again? It didn't go away from the buffet. You really thought that was funny? That was the dumbest thing I think I've said in a long time. She said pi over 8, and I said it because it couldn't get away from the buffet. Well, thank you for humoring me. So your A value is negative. What direction is this working?
Left.
Good. Well, they're going left to right the other way.
Up, left, down, right.
Yes.
Right.
So here's your set of your original values. Now, I want to show you guys how I can write them through. That's all right. Oh, no problem. Would you stop sending mail to yourself at school? Jeez, please. If there's money in any of those, I get half.
Okay.
Now, remember, everybody sees how this shift is going to deal with pi for your h value and 5 for the k value, right? So I'm going to show you how to do this just via ordered pairs before you worry about graphing it. So your set of ordered pairs to begin with are at negative pi over 8 and 1. 0, 0. And then the other one would be at pi over 8 and negative 1. Okay? For the shift, I know that I have to add pi and then add 5 to the x and y values. Do you agree on that? So the easiest of those 3 points to start with is going to be the origin shift. Everybody agree? 0 plus pi is pi. 0 plus 5 is 5. Okay? Now, when I add pi to negative pi over 8, in my calculator, if I don't know how to do the fraction stuff, remember what's happening. It's negative 1/8 plus 8 over 8. What do you get?
Negative 1 over 8.
Yeah, negative 1 over 8 plus 8 over 8 is 7/8. So it's 7 pi over 8. 1. So I'm shifting at pi. It's 1. 1 can be written as 8 over 8. Right. Is it 1 also 4 divided by 4? 2 divided by 2?
Oh, stop.
8. 8 over 8. All I'm doing is just getting the common denominator. Or just use your calculator. All right? Seriously, just use your calculator. In your calculator, if you type it in, if you're not following with that stuff, let me get the right button. Plus 1. Math, enter. Go ahead.
Cute.
He was tackling him. Any second now, let's start.
Don't keep it up.
The little guy is only 7 pounds lighter than my 4-year-old. They're 3 years apart. He's 30 pounds. We went to go get him a bike helmet because we bought a carrier for the back of the bikes and stuff like that. He had to get a 4-year-old bike helmet. One. I have to go buy a really big freezer because I'm afraid of what these children are going to eat when they get to be just this size. Solomon's kids they're just, I think Ryan is bigger. Maddie, yeah, the Solomon's kids are pretty big. But Ryan is a moose. I just call him Moose. I'm going to go by Moose. So, -1/8 plus 1. Math, enter, enter. And it comes up with the fraction for you. Okay? All right. So, remember, that's fine, do it that way. Now remember, all I'm doing here, since these things are, the shifts and everything have pi involved with them, I'm just dropping the pi when I'm using my calculator, because the calculator won't carry it with it. All right? It won't bring it along. So I'm at 7 pi/8, and then 1 plus 5 is? Here you have pi/8, and I'm going to add 1 to it, so that becomes 9 pi/8. Okay? And then -1 plus 5 is 4. Okay? So what I've done here is that I've created my new points prior to putting them on the graph. And I haven't done that with you guys yet. I wanted to see if this is any easier, just to use the calculator to get your values before you move stuff. All right, just another way of doing it. Same thing goes for the asymptotes. Your asymptotes were at -pi/4 and +pi/4, which means I have to shift them pi. So once again, use the same principles of the fraction. -1/4 plus 4/4 becomes 3 pi/4. And this one will be at 5 pi/4. Those are the two new asymptotes. All I'm doing is using the fractions and combining, getting common denominators and going for it. Okay? Now remember, the period itself doesn't change. The period is still pi/2. If you come back over here, pi/2 is the same thing as 2/4. Do you agree? The distance between 3/4 and 5/4 is 2/4, which is the same thing as 1/2. All right? And I'm just talking without the pi in the numerator. All right? Like I said, the weirdest thing about graphing and working with the tangent stuff is that the fractions become a little bit nastier looking because your periods and your asymptotes all get condensed inward. It's not as expanded out as the sines and cosines can be. All right? So now we have all of our new critical values. We can go ahead and just start plotting points from here. I'll start with the asymptotes. I know that my new asymptote will be at 3 pi/4 and 5 pi/4. I know that exactly halfway in between them is pi, because remember, exactly halfway in between the original was at 0, 0. So the new halfway point is at pi. To the left and to the right are 7 pi/8 and 9 pi/8. And now it's just a matter of scaling up the y-axis. Here's 1, 2, 3, 4, 5, 6. So at 7/8, we're up at 6. At pi, we're at 5. And here we are at 4. And there's your graph. So I'm showing you a couple of different ways to write out the tangent shifts. If you're okay working with fractions and it's easier and it was just fine for you to shift everything right there on the scale, go for it. If it's easier for you to write out your original set of 3 ordered pairs and then add the new components for the x and the y value via your calculator, go for it. All right, just trying to show you guys multiple ways of being able to do the exact same thing. Okay? One more? All right, we'll do one more. What's that? All right, take a couple of minutes. So we still got about 10 minutes here. Why don't you take about 3-4 minutes? Try that out. You've got 2 different ways I've showed you to do that. Try it, okay? I'll pause this and we'll come. I know in lieu of time right now, hopefully everybody got that much. Okay. So start with the asymptotes. A is positive, so it's going from quadrant 3 to quadrant 1. Okay. Now to each of these points, I have to move it to the left pi and down 3. Do we agree on that? Okay. Do you want me to do it via the ordered pairs set, or do you want me just to walk it through on the graph because of time? The answer is yes. Okay. I'm just going to do it on the graph because of time. Since I move everything to the left, instead of being at negative pi over 4, I'm now going to be at negative 5 pi over 4. Okay? Instead of being at pi over 4, I'm going to be at negative 3 pi over 4. I do that in my head. Do we agree? Instead of being at 0, I'm at negative pi. Instead of being at negative pi over 8, I'm at negative 9 pi over 8. And this is at negative 7 pi over 8. Okay? All I'm doing is subtracting 1. Instead of being at 0, it's at 0 and negative 3. We went down 3. Instead of being at negative 3, it's at negative 6. Instead of being at 3, it's at 0. And then it's shifted. So this is now negative 6, 3. Okay? Now, obviously, then I would write everything out to list what I had. Okay? So tonight, what I want you to do, just a couple of shifted tangent problems. around this stuff so much. So on page 845, I'll give you 6 of them, 44 through 49. Make sure that you list out your shift points and all that stuff like we've been working on, okay? I know I didn't do this on that last one just because we ran out of time. All right? We will do a short test on graphing, amplitudes and periods, things like that, on Thursday, so we all know.